Okay, so if tangent of alpha is 4/3 and alpha is between 180 and 270, I want to find sine of alpha over 2, cosine of alpha over 2, tangent of alpha over 2. I don't actually know what alpha is equal to, and I don't really need to in order to solve this problem. Alpha is between 180 and 270, and so if this is 180 and this is 270, then that means alpha is in quadrant 3. So here's alpha, it's in quadrant 3. The opposite over adjacent, the tangent, is 4/3. But since I'm going down, it's -4. Since I'm going left, it's -3. So negative over a negative equal positive. And if I did Pythagorean theorem, I would find that this hypotenuse is 5. +5, the hypotenuse is always positive. So they say find the sine of alpha over 2, the cosine of alpha over 2, the tangent of alpha over 2. Okay, so alpha is in quadrant 3. Alpha over 2 is not necessarily in quadrant 3. If I have an angle in quadrant 3 and I divide it in half, so I don't know, well, actually, I can find what it is because I can take tangent inverse of 4/3 and it'll tell me 53, that's the reference angle, just trust the process here. So alpha is 233 degrees if it's in quadrant 3. If I take 233 divided by 2, alpha over 2 is 116 degrees, which is in quadrant 2. And so what that means, all of these different trig functions either have the option of being positive or negative. And I'm looking in quadrant 2. In quadrant 2, the sine is always positive. The cosine is always negative, and the tangent is also negative. So when I say that the sine of alpha over 2 is plus or minus the square root of 1 minus cosine of alpha over 2, the fact that I know what I'm talking about, these angle over 2 ends up in quadrant 2, the only answer is the positive one. If all of that went in one ear and out the other, try the positive answer, and if it's wrong, try the negative answer, because it has to be one or the other. So I'm going to find sine of alpha over 2, and it's the positive version, so I don't need to put a plus sign out front. So the square root of 1 minus the cosine of alpha. Well, the cosine of alpha is adjacent over hypotenuse, so -3/5 all over 2. So let's simplify that numerator. So I've got plus, it becomes plus, and 1 is the same thing as 5/5. So 5/5 plus 3/5 is 8/5. Divided by 2 is the same thing as 8/5 times 1/2. And so those cancel and I get 4, the square root of 4/5. Which they might take as the answer. They might make you rationalize the denominator. So the square root of 4 is 2, and the square root of 5 is √5. So then I would multiply by √5, so I would get 2√5 over 5 for the answer. So I think that's what they'll look for. They might take √4 over 5. But it is positive because the alpha over 2 angle is in quadrant 2 where sine is positive. I don't know. It'd be confusing for me to explain that in class, so I'm sure it's only more confusing over the internet. But it is positive. The cosine of alpha over 2 is negative, so I'm going to take negative square root of 1 plus cosine of alpha over 2. So it's plus in there because I'm finding the cosine of alpha over 2 formula, and it's negative because I decided that it needed to be negative. So I think I'm actually going to erase this because it's a video and you can rewind so that I have room. Okay, so the cosine of alpha is still 3/5, but I'm taking, so negative square root 1 plus negative 3/5 over 2. So 1 is still 5/5, but 5/5 minus plus a negative is 2/5 divided by 2, which is the same thing as 2/5 times a half. So those cancel and you get 1/5. So let's see, negative square root of 1/5 might be an okay answer. They might take the square root of the numerator and the denominator 1 over √5, and it is negative. So So when I multiply by root 5 over root 5, I would get negative root 5 over 5 for the answer to the cosine of alpha over 2. And then the tangent of alpha over 2 is negative, and I can do one of two things. I can use the formula, or I can take sine of alpha over 2 divided by cosine of alpha over 2, except I erased the cosine of alpha over, or the sine of alpha over 2. So let's see, the sine of alpha over 2, didn't it end up being 2 root 5 over 5 was sine of alpha over 2, and then cosine of alpha over 2 was negative root 5 over 5. So let's take sine divided by cosine. So 2 root 5 over 5 divided by root 5 over 5, which is the same thing as 2 root 5 over 5 times 5 over root 5. So the root 5's cancel and the 5's cancel, so the tangent of alpha over 2 actually just ends up being 2. Negative 2. Where did I lose my negative? This was a negative. So this was a negative, so this was a negative. Negative 2. Yeah, it's complicated. I don't know what to tell you. If you're saving this until Friday at 2 o'clock, I apologize to you for that decision. Let's try this practice problem. So secant of alpha is equal to negative 3. And alpha is between pi over 2 and pi. So that's just code for what quadrant I'm in. So alpha is between pi over 2 and pi. Well, pi over 2 is right here. Pi is right here. So this means alpha is in quadrant 2. And so the secant of alpha, so secant is the reciprocal of cosine, so secant is hypotenuse over adjacent. And so negative 3 over 1, hypotenuse over adjacent is, well, hypotenuse can't be negative, so 3 over 1, it's the adjacent that ends up being negative. So I'm taking negative 1 squared plus b squared equals 3 squared. So 1 plus b squared equals 9. B squared equals 8. And then when I take the square root of 8, b is the square root of 8, which ends up being 2 root 2 when you simplify the radical. So this opposite side is 2 root 2. I actually don't think we really need it because we're finding all of these formulas only have cosine in them, but so. So let's think about this angle. So I'm actually going to, so this is the work behind the screen, pay no attention to me. If I take cosine inverse of negative 1/3, I get that this angle is 109 degrees. And when I take 109 divided by 2, I get 54. So alpha is in quadrant 2. Alpha over 2 is in quadrant 1. And in quadrant 1, everything is positive. So all of my answers are positive. So again, if that really doesn't make sense, you can definitely ask, or you can just try the positive version and then the negative version. So the sine of alpha over 2 is the square root of 1 minus the cosine of alpha. The cosine of alpha is negative 1/3. So 1 minus negative 1/3 all over 2. So let's think about that numerator. 1 plus 1/3 is 3/3 plus 1/3, which is 4/3 divided by 2, which is the same thing as 4/3 times a half. That ends up being 2. So I get the square root of 2/3, which is the same thing as the square root of 2 over the square root of 3. When I multiply by root 3, I get root 6 over 3. So that is the sine of alpha over 2. Either the square root of 2/3, or they'll make you rationalize the denominator, root 6 over 3. Give myself some room to find cosine of alpha over 2. So I'm going to be taking, for cosine of alpha over 2, the square root of 1 plus the cosine of alpha. Well, the cosine of alpha is negative 1/3 over 2. So 1 plus a negative 1/3 is 3/3 minus 1/3, which is 2/3, divided by 2 is the same thing as times 1/2. So cancel that out and get 1/3. So then it's the square root of 1/3, which just ends up being square root of 1 over 3 is 1 over root 3. So you get root 3 over 3 for the cosine. And then the tangent of alpha over 2, I can use the formula, or I can take sine over cosine. So I can take root 6 over 3 divided by root 3 over 3, which is the same thing as times 3 over root 3. So those cancel. Root 6 over root 3 is the same thing as the square root of 6 over 3, which is square root of 2. So the tangent is square root of 2.